At the construction of a parabola using locus or eccentricity method. Construction of a parabola using locus or eccentricity method. And the question that I'm going to use here says, draw a parabola when the distance between its focus and directrix is 50 millimeters. Also draw a tangent and a normal at a point 70 millimeters from the directrix. I'll read the question again. Draw a parabola when the distance between its focus and directrix is 50 millimeters. Also, draw a tangent and a normal at a point 70 millimeters from the directrix. That is the question that we are going to use. So let's see how the construction of a parabola can be done when we are given a distance between its focus and directrix, and then we also draw a tangent and normal to it using locus or eccentricity method. So what we are to do first is to position the directrix. So position directrix. So directrix is the vertical line. So we draw a vertical line of any length. It doesn't have a particular length, so you can just draw like this. Okay, so this is directrix. So I'm going to label this. So I'll call this point. So this is A and this is B. So we have directrix to the line AB. And then so from here now, so somewhere in the middle or somewhere around here, I'm going to draw a horizontal line. So this is the axis of the parabola. So I will call this, so this is line CD. So CD is the axis of the parabola. So also it has no length. Okay, then the next thing that I'm going to do is that, so we need to position the focus of the parabola. We need to position the focus of the parabola as we are told in the question that the focus is 50 millimeters from directrix. So this is directrix. So we need to fix the focus on this line CD. So from point C, we take a measurement of 50 millimeters. Take 50 millimeters. So from point C on the directrix, so take 50 millimeters. So here is 50 millimeters. So this point here is point F. So that is the focus. So add the focus here. Okay. Now, so having located the focus here on the axis, so the next thing that we are going to do is to position the vertex of the parabola. So we have to position the vertex of the parabola. So what we are to do, as you are told, as you have been informed, that the eccentricity of a parabola is 1. The eccentricity of a parabola is 1. Okay, so when we are talking about the eccentricity, so so that of the ellipse is less than 1. The eccentricity of a hyperbola is greater than 1. But when it's come to a parabola, its eccentricity is equal to 1. So what we are to do now, we are going to divide the distance between the directrix and the focus by 2. So if the distance between the directrix and the focus is 50 millimeters, divide 50 millimeters by 2, and that will give us 25. Okay, so which means that from either point, either C or F, so we take a measurement of 25 millimeters. So here I have this to be 25 millimeters here. So this point here is where I have the vertex of the parabola. Okay, now so eccentricity now is now equal to, so we now have eccentricity to be equal to VF over VC. So if VF is 50 and VC is 50, so sorry, if VF is 25, sorry, if VF is 25 and VC is 25, so 25 divided by 25 will give us 1. So that is the value of the eccentricity of the parabola. So now, next thing that we are going to do is that we need to bisect distance VF. Okay, so because so I will have, supposing it's 20 millimeters, So I will have just taken a measurement of 10 millimeters from V or 10 millimeters from F, but because this is 25 millimeters, so I need to bisect it. So I need to divide it into two. Okay, so I will make use of the compass to do the bisection. So putting the pin or the compass here, I will draw an arc up here and down here. Okay, then so I put the pin here at F with the same radius, draw an arc up and draw an arc down. So I'm going to draw the bisector of VF, okay, and that will be the midpoint of line VF. Alright, so draw the bisector. Alright, so we have this as bisector of VF. Then the next thing that we are going to do is that we need to position some other points on this line. So this point here, so where the bisector meets line VF, so I'll call it point 1. So this is point 1 here. Okay, so we need to locate other point. I want to put like 5 here. So this is 1 already. So this point F here, so this will be point 2. Okay, so this will be point 2. Okay, then I need to add 3 to it. So to do that, I will take distance 1 and 2 with the compass like this, or use your divider to take the distance. Okay, so put the pin here and then make an arc on this line. So this is 3. Then put it here, so make an arc again. So this is 4, and then you put it here, so make an arc here. Here we have 5. So 5, 4 or 5 are okay. So here I have, this is 3, so this is point 3, so here is point 4, and this is point 5. So at this point, so I'm going to erect a perpendicular line. So I erect perpendicular line. So set the set square on the T square like this, and then so you draw a line like this. Okay, so bring it to this point 3. So and also so draw a line. So we have this. So set it here at this point. Then we draw a line and bring it to this point here and draw. Alright, so we have this. So then the next thing that we are going to do is very simple. So just listen to what I'm going to say here. So we are going to make use of radius. So we are making use of radius okay, center F. So center F. So that's going to be the center that we are going to use. So center F, that is the focus. So center F, we are making use of this point. But the radius that we are going to use, we are using radius C1. Okay, so radius C2. Okay, then we are using radius C3. Okay, and then radius C4, and then we are using radius C5. Okay, so all right, so this is what I mean. So we are going to put the pin of the compass here at C, extend to 1. So extend to 1. So we are taking this radius C1 and lift it up like this. Now position the pin at point F and make an arc on line 1 up and down line like this. Okay, now so you go back to point C, put the pin at C on the directrix, extend the pen point to point 2 on the line. So lift it up like this and position the pin on point F now on the focus, make an arc up and make an arc down on line 2. Then go back to point C on the directrix, extend the pen to point 3. Okay, so extend to point 3. Okay, so lift it up and then put the pin at the focus like this, and then make an arc on line 3 up and down. Okay, then go back to point C on directrix, extend the pen point to point 4. Okay, then so lift it up, okay, put the pin on the focus and then make an arc up and down line 4. And then so go back to point C on the directrix, extend the pen to point 5. So this is C5 now. Okay, so then so lift it up, put the pin at point F on the at the focus. Okay, so make an arc up and down line 5. So we are done with this. So these points are what we are going to join together to obtain the parabola. So we are going to make use of this point. We are going to join them together with the use of French curve. So including point V. So we also have this point. So we have this point here. So here we have this point. So this point, and we have this point here. So we are joining them together to obtain the parabola. So we make use of the French curve. So set the French curve on the point. Okay, so adjust it. All right, so with what I have here, I can go on and join all these points together. Okay, so it goes like this. All right, so we have this now. So we turn it. So turn it. So we adjust it up here. Okay. All right, so I can go with all these points. So just come to this point, and then so you join them together like this. All right, so here I have the parabola. So this is the parabola. Okay, now so let's go and answer the remaining part of the question that says that we should draw a tangent and a normal at a point 70 millimeters from the directrix. We are to draw a tangent and a normal at a point 70 millimeters from the directrix. So this is directrix. So what we are to do is to take a measurement of 70 millimeters from directrix. Okay, so you set the ruler, so set the 0 point at point C on directrix. Okay, then take a measurement of 70 millimeters. Take 70 millimeters. So here is 70 millimeters here. Okay, then at this point, so draw a vertical line. So draw a vertical line up to touch the curve. Okay, so draw a vertical line. So from this point to touch the curve, so we take a vertical line up like this. So it touches the curve at this point. So this point is point P. So this point, so we have P at this point. So write P here. Okay, so this is the point on which we are to position the tangent and the normal. Okay, so what we are to do now is that we are to join point P and F together. So join PF together. So join PF together with a straight line like this. All right, so then you take your protractor, take the protractor, so place the center of the protractor at point F, and this line on the protractor, set it on PF. This is what I mean. So just set like this, center on point F, and then the line on PF. So look at the way I'm setting it. Okay, so there is it. All right, so you set like this. All right, so then you go on 90. So on this line, 90 degree. So put a dot on the paper like this, or just mark it. Okay, so now, so draw a line from point P here. So draw a line from point P, from point F. Draw a line from point F to touch the directrix like this. Okay, so let's call this point, let's call it point E on the directrix. So this is point E on directrix. Okay, so we have this now. So now, so the next thing that we are going to do is that, so now draw a line. So draw a line from E to pass through point P. Okay, so you set like this. So make sure you can see the point P on the curve a little. Okay, then draw a line from E, so to pass through point P like this. So we have this. Okay, so now, so let's bring out the tangent. So we make this line so thick, not from here, so just to stop somewhere around here. So make it a thick line as the tangent to the curve. So this is it. All right, so here we have the tangent to the curve. I will call it line RS. Line RS. So the tangent is RS. Okay, so let's now bring out the normal. So this is the tangent. RS is the tangent. Now let's now work out the normal line. So let's look at how we can do that. Okay, so what we are to do is that, so the angle between a tangent and a normal is 90 degrees. So the angle between a tangent and a normal is 90 degrees. So just take your protractor, set the center point at point P here, and this line on line RS, this is what I mean. So the center point on point P and the line on RS like this. So you set it like this. Okay, so this is okay. Okay, so then you put a dot on 90. So the paper is not on the paper, so I have it like this. So all I'm going to do, so set the ruler or the protractor like this. Use this side of the protractor. Okay, set like this, and then you draw a line from point P. So draw a line from point P. So just a line like this. Okay, so I can see the point that I put here. So like this. So this is long enough. All right, so here I have this line to be line PQ. So this is the normal line. So PQ is the normal. So then the angle between them is 90 degrees. The angle between them is 90 degrees. So here I have the tangent RS and the normal PQ. Okay, so we are done. So we have constructed this parabola with the use of locus of eccentricity method, and then we have been able to draw a tangent and a normal at a point on the curve. It's as simple as I've done it here. Thank you and God bless you.